Welcome to lesson 1.10. Today we're going to talk about matter and the ways that we can classify matter. Matter, by definition, anything that occupies space and has mass, chemistry in itself, is the study of matter. Matter can be classified in a lot of different ways. We're going to start off with which state matter can be classified in. This lists solid, liquid, and gas. You may have studied in your junior high school class that if you talk about the universe as a whole, you have a fourth state of matter, and that's called plasma. But we're going to focus on solid, liquids, and gases because plasmas seldom exist on this planet. A solid is, by definition, rigid. It has a fixed volume and shape, and you cannot push it together. So there are a lot of empty spaces in this solid, but it's not very compressible. It's only slightly compressible. A liquid has a definite volume, no specific shape. So for example, if I were to take 50 milliliters of water and put it in a beaker and then put another 50 milliliters of water in an Erlenmeyer flask, those things would have the same volume, but they would take on a different shape. Liquids also have empty spaces, but they are, again, only slightly compressible. A gas, on the other hand, a gas has no fixed volume or shape. It will take on the shape and the volume of its container. So in this particular case, if we put 10 molecules of gaseous water in this flask, those 10 molecules would occupy the whole flask. Would it have a high pressure? No. But they would try to occupy the whole flask. If I put 100 molecules in there, same thing, it would try to occupy the whole flask. So it's going to take on the shape and the volume of that container. Gases are highly compressible. There are very large spaces in between those gases, and so we're able to decrease the volume of those gases very easily. First, let's talk about mixtures. Mixtures are another way we can classify matter. Mixtures have variable composition. Two different types of mixtures. A homogeneous mixture is also called a solution. A homogeneous mixture, you cannot see the separate parts of it. So for example, a homogeneous mixture might be salt water. A homogeneous mixture might be something like the air in this room around us, the nitrogen, the oxygen that are making up the air in the room around us. Another type of solution is actually, a solid type of solution is brass, the combination of copper and zinc. You cannot distinguish the parts in those. A heterogeneous mixture, on the other hand, has very distinguishable parts, and you can see the separate parts. An example I like to use a lot is a chocolate chip cookie. You can see the different parts of the chocolate chip cookie, or maybe even a monster cookie. That would give you more distinguishable parts. Most of the matter around us is mixtures, and a lot of times it's not usable that way, so we need to separate it into pure substances, and we do that by physical means. By using a physical means, that means we're invoking a physical change, and so we're changing the form of the substance. We're not changing the chemical composition. An example of a physical change would be boiling water, going from a liquid water to a gaseous water, or perhaps freezing water, going from liquid water to solid water. We do these physical changes to separate mixtures into pure compounds. We can actually get down into elements when we use physical changes, but we cannot go lower than that. So we cannot actually break those compounds down into elements, but if one of those parts of the mixture was an element, then we can get an element out of it. So let's look at three ways of separating mixtures. One we use in organic chemistry a lot is called distillation, because distillation looks at the boiling points of different substances. So let's look at this apparatus, and let's say we have a methanol water mix. Granted, we would not use a Bunsen burner in that case. We would use a heating mantle, but we have a water methanol mix. Methanol boils at a much lower boiling point than water. And so we have this thermometer up here, and what's going to happen, we get this mixture to boiling, and this thermometer will rise up to the boiling point of methanol, and the methanol will be driven out of the solution, and it will come up here and go down this tube. This is called a condensing tube, and this has cold water in the outer part, and the methanol is in the inner tube, and as it goes down, it's cooled by the water, so it goes from a gaseous phase to a liquid phase, and then it drips out the end. When all the methanol is out of the solution, your thermometer will spike. It'll have a large temperature jump, and that large temperature jump will indicate that we've boiled all the methanol out of here. All that's left to boil is the second substance. And so if we have substances that have a great difference in boiling points, a simple distillation apparatus like this works very well. Occasionally we're going to run across substances, or we're going to run across a mixture that has a lot more things in it, and the boiling points are much closer together. And so we have to use a more elaborate condensing tube, or a more elaborate setup, or maybe we have several of these flasks and we do a step-by-step distillation. Filtration is another way to separate a mixture. In order to be able to filter something, your mixture has to be a solid liquid combination. And when you pour that solid liquid combination through a filter, that filter catches the solid and the liquid moves on through. The third thing we're going to talk about is chromatography. Chromatography is a very broad term for a lot of different things we do in chemistry. In chromatography, we have a couple of different phases. Most often the stationary phase is solid, and then the mobile phase can be a liquid or a gas. And what happens is the substances you're trying to mix have different affinities for those two phases. So for example, if it has a higher affinity for the solid phase, it's going to stick to that solid stationary phase until we can do something, say raise the temperature high enough to drive it off of that. The example you do most often in elementary, junior high, high school science is paper chromatography. So here we have a solid phase, that's the filter paper. The liquid phase is water, or maybe some kind of water alcohol mix. And as we let it develop, the water moves up the chromatography paper, and it separates out the colors of ink on there, because those different colors have different affinities for the phases. Another way to classify matter is by considering whether or not it's a pure substance. So we had mixtures or we had pure substances. The two different types of pure substances are compounds or elements. A compound is a substance that is pure, but it still can use a chemical process to break it on down. You cannot break it down into its elements via a physical process, but you could use a chemical process. So compounds go through chemical changes or chemical reactions, and they can make elements. A lot of times they'll make other compounds. An element can be broken down into it cannot be broken down into simpler substances by physical or chemical means. An element is as small as it gets in terms of using things that we do in the chemistry lab, like physical or chemical changes. You can use nuclear changes to actually break that down smaller, but that we won't be using those. We may talk about them briefly. This particular flowchart gives a really good way to classify matter. So if you have an opportunity, you can either stop this video and copy this down, or use the slide or use the PowerPoint that's given to you on your Canvas or your Northwest Online. So let's do this quick question and talk about solutions. A solution, by definition, is also the correct choice is homogeneous mixtures, just simply because by definition that's what it is. Okay, this next question on the last slide in this PowerPoint asks which of the following statements is false. We didn't cover a lot of this through this PowerPoint, but let's just kind of talk through it. And we did cover solutions are always homogeneous mixtures. That particular statement is true. We did talk about atoms that are in solids, but we didn't really talk about the fact that they're mostly empty space. You saw holes in them, but it's not until we talk about Rutherford and the discovery of the atom, or discovery of the nuclear atom through the gold foil experiment, that you find out that they're mostly open space. But atoms are mostly empty space. Elements can exist as atoms or molecules. That is true. A lot of the elements on the periodic table their smallest form is an atom, but there are a few elements on the periodic table that are not stable unless they are diatomic or even greater. Most of the time we just look at the diatomics like nitrogen, oxygen, hydrogen, and so forth. So elements can exist as atoms or molecules, and that leaves D to be false. Compounds can exist as elements or molecules. Well, a compound cannot be an element because those are different types of pure substances. So the correct answer on this one is D. And that concludes Unit 1. So you should be ready to do the sapling Unit 1 homework. And then, once you're done with that, the next lesson we'll start on is Unit 2. And in Unit 2, we're going to talk about atoms, molecules, and ions.